So as you guys can see, we have a speaker, and they all have subwoofers on them. So I'm gonna prank me residential hall.
Hits your eye like a
Turn your
pizza
speaker
pie
off!
For
that's
me, for my physics slider.
Physics man, stop putting
when
names
the
in your
world seems to
physics
shine
slider!
like it had.
So by the way, guys, the fighting was fake, the prank was fake, everything was fake, including this black eye, purple a purple washable marker, and what isn't fake is the description has both the problem and the givens. So yeah. So for part A, we are supposed to be finding the frequency of the subwoofer. And so first we have to find the wavelength since we don't have the wavelength, nor do we have the frequency. We're looking for the frequency, but we need the wavelength first. But we can get the wavelength by with this equation. So we are given that the hallway is a big tube. One end is open, the other end is closed. So that means we have to use this equation 4L over 4 times the length of the hallway divided by the number of the order equals the wavelength where n equals whatever the order is. So and in this case it's just 1. So lambda in this case would be 4L, 4 times the length of the hallway. So for step 2, we have to find the frequency. Let's bring back our fundamental equation for the wavelength in respect to frequency. So as you can see, we can switch. We're looking for frequency, so we can just switch the f and lambda. So it's just frequency equals velocity divided by the wavelength. So yeah, we are given that the lowest order possible would be the first order. So that's why we did 4L. So we can plug in 4 times the length of the hallway for lambda. And we are given that the speed of sound is 333 meters per second, so plug that in for V. And then we can plug in 14.3 for L. And then if you do the calculations correctly, which I probably didn't, or I did, your answer would be 5.997 meters, or just 6 meters if you're going for significant digits. Anyways, that's your answer. That's my answer for part A. So part B, you can find out. Is there any other orders? The question is asking. So yes, there are higher orders, except they're only in the odd number since it's only odd number. It's only odd number orders only because it's open closed. So that would mean that it's odd numbers only. So as you can see, the first order is this blue line. Sorry if you are colorblind. Uh, this is straight blue line, and then the dotted yellow line is the third order. So it's not that good. And then you see the red wavy line. That is the fifth order. So there are higher orders. They are all based on this equation. So that's how you find the higher orders. So now we have to find if there's any orders close to 18 hertz. So we have to do this ruling process of checking every odd number since this is an open and closed tube. So yeah. So we already calculated in the first order. So let's calculate for the third order. So n equals 3. Uh, so so we can plug this in for lambda. Let's get the fundamental equation for frequency and wavelength in, and plug in 4L over 3 for lambda. Or we can just put 3 and multiply the velocity by 3 and then divide it by 4L. So yeah, plug in all the numbers and then you would get 17.996 hertz, and that's essentially 18 hertz. So 18 pint hertz. So yeah. So basically your answer should be the third order for C.